5.1, using transformations to graph quadratic functions. First off, we need to know what a quadratic function is. It's in the form of f of x equals a times the quantity x minus h squared plus k, where a does not equal 0. We're going to look at parent functions. The linear parent function is where f of x equals x, or y equals x. Goes through the origin, straight line. The quadratic parent function is f of x equals x squared, or y equals x squared. And the graph of that is a parabola, or a U-shaped curve. And you can see that graph right there. So we can apply transformations to this parent function. So the first thing we're going to do is we're going to describe the transformation, and then we're going to graph each function. So if we look at the first one, let's look at the parent function. F of x equals x squared. So let's graph that first. So when x is 1, y is 1, x is negative 1, y is 1, 2 is 4, negative 2 is 4. So the parent function looks like that. If we graph g of x, think of a table, put 1 in for x, and we get 17. It's way up here. Put 0, you get 9 plus 1 is 10. Put in a negative 1, you get 2. Squared is 4 is 5.
No time are you to make contact by any means with Mr. Jackson on this part.
Negative 2, you get 1. 1 squared is 1, plus 1 is 2. Put negative 3, you get 1. Put negative 4. And you get negative 1 squared is 1, get 2. So you see it would start.
Yeah, sorry.
So this moves 3 units left and 1 unit up. And if we look at standard form, this would be x minus negative 3 squared plus 1. So you can see where the left comes from the minus 3. Looking at the next one, standard form is x minus h, quantity squared, plus k, where the h moves it left or right, and the k up or down. So if I look at my h equals 2, it's going to move it to the right, and my k equals negative 1, so it's going to move it down. standard form. I'll do in blue of the parent function. So there's our parent function. So I move it 2 to the right and 1 down. So it would look like that. Okay, so in the check it outs, again, let's graph the parent function. So graphing the parent function, 1, 1, 2, 4, negative 1, 1, negative 2, 4. There's your parent function. And then write standard form, which would be x minus 0 squared minus 5. So it just moves 5 units down. So it would look like this. And you see that it is symmetrical in nature. So this would be just 5 units down. So find your h, find your k, graph your parent function in one color, and then graph your transformation. Go ahead and do the second one. And it would look, and we don't have to be particular on how we graph, as long as you have the vertex where it belongs. Okay, now we'll talk about reflections, stretches, and compressions. So looking at reflections across the y, we're going to put the negative sign with the x. So inside parentheses. When we do a reflection across the y, it goes outside the parentheses. So inside, outside. When we do a horizontal stretch or compression, the factor goes 1 over the factor with the x, just like we did before. And then the vertical stretch or compression goes outside the function. So let's recap. How does the operation sign inside the parentheses affect a horizontal translation? Okay, so think about your x minus h squared plus k. H is the horizontal translation. So if h is greater than 0, moves it right, less than 0, moves it left. And then if we talk about the vertical translation, that's our up and down. So that's our K. So if K is greater than 0, moves it up. Less than 0, moves down. Now we can focus on those stretching and compressions. Again, remember, outside. So we're going to look at our function has a negative outside. Parent function looks like this, and you should just memorize -1 is at 1, -2 is at 4, 0 at 0. There's our parent function. So when I graph transformation, the negative means a reflection across the x. And then the 4 is a vertical stretch. So two things are happening here. It's turning upside down, and it's coming in. So plotting points, and you can do this through Desmos. Plotting points, 1 is going to be at 4, but -4, so it's upside down. -1 is going to be at -4. And then this will be at 16, so it's down here pretty far. So it'll look like this, coming in closer to the y and upside down. In the second one, graph our parent function. Okay, remember the parent function is always y equals x squared. And then graph the transformation. So what's happening is we have 1 over b x squared. So my b equals 2. So that's a horizontal stretch. By a factor of 2. So it's going to stretch out. And again, put that in Desmos. Find your points, a few points.
Message is received from 24742.
So I put a 2 in there, and I'm going to get 1. I'll put a 4 in there, and I'm going to get 4. So it would look like that. Okay, so try to check it out. Think about if it's inside parentheses, outside parentheses, and if it then would be upside down by a reflection, if it's being stretched out. So if you got stuck, again, let's do this parent function. Right, let's look at what's happening here. It's inside parentheses and it's a factor, so my 1 over b equals 2. So b equals 1/2. So it's a horizontal compression by 1/2. And that's the only thing that's happening. So this is coming in closer to the y-axis. So at 1, it's actually at 4. So it's going to be real close. Something like that. The second one, again, parent function. And what's happening here? The negative means it's reflecting across the x-axis. It's outside parentheses. The 1/2 means is it vertical because it's outside compression. So what's that going to look like? It's going to be upside down and it's going to expand out. So it's going to stay at 0, 0. Put a 2 in there. -2. -2 is going to be -2. Put a 4 in there. It's going to be 8. And again, use Desmos to help you. Okay, so now you're ready for assignment 1.